Hi folks, welcome to another session on competitive math prep. The problem that we're going to discuss today is this. What is the least 4-digit number that when it is divided by 3, 4, 5 or 6 leaves a remainder 2 in each case? The options given to us are 1012, 1022, 1122, 1222. So what we get from this problem is if a number leaves a remainder 2 when divided by 3, 4, 5 or 6, it means that if we take away this remainder 2 from the options, then the results would be exactly divisible by those numbers. So let's take away the remainder 2 from each of the options. So these are the given options and we are going to take away 2 from each of these, which gives us 1010, 1020, 1120 and 1220. The option which is exactly divisible by 3, 4 and 5 will be the correct answer. If you notice, we have eliminated 6 here. We don't really have to divide the options by 6 because if 3 and 4 can divide some number, then that number can be exactly divisible by 3 multiplied by 4. Since 3 and 4 are relatively prime to each other, so that number will be exactly divisible by 6. So now let's begin with testing which options are divisible by 3. Let's start with 3. Option A, the sum of the digits is 2 and 2 is indivisible by 3. Option B, the sum of the digits is 3 and 3 is divisible by 3. Option C, the sum of the digits is 4 and 4 is indivisible by 3. Option D, the sum of the digits is 5 and 5 is not divisible by 3 again. So out of the 4 options, only option B is exactly divisible by 3. Since all the other 3 options failed in the first hurdle itself, we can just ignore them and conclude that option B is the correct answer. No need to try dividing them by 4 and 5. If you want to know how to find whether a particular given number is exactly divisible by 3 or 4, please see our shorts video for it. And if you also want to know what relatively prime is, again, please refer to the same video. Now let's move on to the conventional solution. We need to find the smallest number that when it is divided by 3, 4, 5 or 6 leaves a remainder 2. For this, we'll have to find the LCM, the least common multiple of 3, 4, 5 and 6. Since 3 is already a factor of 6, we can ignore it and it's just enough if we find the LCM of 4, 5 and 6. The LCM of 4, 5 and 6 is 60. So 60 plus 2 is our desired number. However, we have to find the smallest 4-digit number, which when it is divided by these numbers leaves a remainder 2. So what we have to do is we'll have to divide each of the modified options by 60. Please note you have to divide the modified options, not the original options, because if you divide the original options, you will still be left with a remainder of 2. Now, so you will have to divide each of the modified options by 60 and see which is exactly divisible. So take the modified options, 1010 divided by 60. So just cancel out the zeros. 101 divided by 6 is 16.83. Similarly, 1020 divided by 60 will be 102 divided by 6, which is 17. This is a whole number. Option C, 1120 divided by 60, which will be 112 divided by 6, which is 18.67. The next one is 1220 divided by 60, which is 122 divided by 6, which is 20.33. So out of the 4 options, you can see that only option B is exactly divisible because it leaves a whole number, no remainder in here. So option B is the correct answer. Some points to note here. The competitive method gives us the solution in a fraction of the time as the conventional method. And the time saved from problems like these can be used against problems that can be solved only using the conventional methods. Also, there are no points for effort or additional steps, so the quickest method is always the best approach. We really hope you found this useful. Please subscribe and also share this with others who may also benefit from this. And if you have any questions for which you might need the competitive solutions for, please let us know in the comments and we'll get back to you. Thank you for your time today. Looking forward to connecting with you all soon. Have a great day.